Good afternoon. My name is Hunter Carpenter, Senior Director of Public Policy for the Agricultural Retailers Association. Welcome to the fifth and final webinar in a series ARA is hosting in coordination with CPDA, the Council of Producers and Distributors of Agrotechnology. The goal of this webinar series is to develop a uniform industry adjuvant education program for the ag retail industry so we can help growers understand how the selection and use of the proper adjuvant will improve their overall crop protection program. This webinar will give a continued look at the individual categories of drift and deposition aids, and we will explain the different types, when to use, and how to optimize performance to help the grower improve results. We would also like to thank Growmark for sponsoring today's webinar. We greatly appreciate your continued support. Today's featured speaker is Joe Janalski, Director of Education for the Adjuvant Development portion of CPDA. Joe has over 40 years of experience in the development of adjuvants and spray application technology. 35 of those years were with the legacy Winfield United companies. Joe also holds 41 U.S. and international patents on the composition of new agricultural adjuvants, wind tunnel design, and application technology. He is the author of numerous scientific publications on these topics. Certified crop advisors attending today's webinar can earn one CCA program IPM CEU. At the completion of the webinar, a QR code will be displayed for attendees to scan using your mobile device, so stay tuned. We would also like to take this time to thank the CPDA Advisory Working Group and acknowledge their contributions in helping plan this series of webinars. Thank you for all your hard work. I'll remind everyone that Joe plans to take questions at the end of his presentation, but you can submit questions at any time using the Q&A function provided by the Zoom webinar application. This webinar is being recorded and will be made available on our website, aradc.org. Webinar recordings and slides are made available to all ARA members and can be accessed on the member homepage. If you need help logging in, email info@aradc.org. Without further ado, I will turn it over to Joe Janalski with CPDA for today's presentation. Joe?
Good afternoon, or I guess still morning somewhere to everyone, and thank you for joining us today. I realize for a lot of our retailers, we're right in the thick of things as the weather is broken. A lot of people are trying to get serve their customers as they're starting to get planning. So other than in the north where there's still some snow coming. Drift and deposition is a passion of mine. Been working at it. I actually taught for over 30 years, taught applicators on spray application from very early days when I first started working all the way back to Land O'Lakes Incorporated. I do want to thank the other members that helped put some of these slides together. Johnny Roberts, and then in particular, other advisory group that donated many of these slides, particularly my alma mater, Winfield United, that I was able to, they kindly let me use some of their slides. So with that, we're going to start about what we're going to talk about today. First, we're going to talk about some basic definitions. We need to talk about why so few acres get a drift and deposition aid. Going to talk about the differences between the two and why it's important to use them in all applications. I'll talk briefly about CPDA Application Enhancement Program and how that can help in the future, and then a little bit on the Endangered Species Act. Let's go to the next slide, please. So the basic definitions, ASTM is the standards committee for the application technology areas. Three important terms: deposition aid, a material that improves the ability of agricultural chemical sprays to deposit on the targeted surface. Extremely important. If you're putting a $40 herbicide program in a spray tank and you lose 20% of that, that's really, really easy math of what you're throwing away. drift reduction agent, material used in liquid spray mixtures to reduce driftable fines. So these two really are essentially the same. A drift reduction agent, if you're reducing driftable fines, you're also a deposition aid. The STM also termed driftable fines, and right now that is setting at 105. Now that does include the aerial application business, and that's why the 105 number. Some CPDA members were looking at getting an addition put for ground application to move that to 150. Next slide, please. As I said before, basically, a drift and deposition is really the same. If you reduce the fines, the drift control agent from a spray pattern, you increase the deposition of the percent of the spray volume applied onto the intended target, thus a deposition aid. Next slide, please. And I use this, and this is a slide that was done many years ago with a on fungicide application with a high boy and looking, I don't think you can see the logo down below. This was with 20 GPA, an 8003 spray tip. And the only difference between these two applications were the one had the fungicide and alone, and the other had a deposition aid included with it. And the visualization of this, and this was a replicated study using water-sensitive paper. It was analyzed, and these are the numbers and the representation that this shows. So you went, that spray tip created a lot of fine spray particles, and because it was right on the top of this corn, it deposited very well right on the top few leaves, 60% coverage, where with the deposition aid, it helped that lower coverage. Everybody knows the fungicides, you really want them around that ear leaf area, that 5 foot mark, and you went from 7% coverage to 22% coverage. Again, $20 fungicide application, you increased it 15%. There's a lot of value in that. So keep this picture in your mind, why deposition agents are important. Next slide, please. So what percent of your applied acres use the drift and deposition aid? I guess you can go to your individual retail. If you're doing custom application, how often are you putting a drift deposition agent in there? As you deal with your growers, how many of them are using one? Our best guesses for the industry is probably 15% on the low end. And if a retailer is working this really hard, they might be getting up to 25%. Still very, very low. Next slide, please. So why are drift and deposition agents not used? And I think the biggest factor is we have nozzle manufacturers putting great new technology on the spray tips of your sprayer. And if you put thousands of dollars in an ultra low drift spray tip, why in the world do you need a drift control agent in it? It's also the additional cost. That's assessed right at the application. If you're putting another $250, $3 in that spray tank, it's going against that application cost. It continues to build an already expensive program. So also one extra thing to put in the tank. And then I think the real problem is the perceived lack of value. Next slide, please. So the perception of drift control, I think, is really owned by the spray tip manufacturers. They've done a lot of great work getting spray tips that do very well at reducing fines. We use the pulse systems, which keeps this consistent pressure throughout the application, which is a great tool. And just putting that spray tip on, it's easy once it's on there. Even if you've got one of those, the one that you can turn 3 or more spray tips, it's relatively easy. It's perceived as doing everything you can. And it is not assessed to the per acre cost of that actual application. You put that money in those new tips maybe a year or more ago, and it really isn't assessed against the the actual application. Next slide, please. We feel that drift reduction spray tips are just the first step. Different applications require different sizes of droplets, and therefore we have hundreds of different types of spray tips to choose some for those various needs. One reminder here, however, the spray tip chart that you often look at to see which one I should use, these are definitions of that spray tip with water, not what they actually deliver when a herbicide, an adjuvant system, or fertilizer, or any other thing you put in that spray tank is in there. You may have something different than what the nozzle manufacturer chart says. Next slide, please. So in other words, that perfect medium-sized spray tip with water may now be in a fine category when you put glyphosate or many other herbicides in the spray tank. We propose that a deposition aid can move you back into that intended medium spray and deliver more product to the intended spot. Next slide. This is an old slide from back from our one of the earlier wind tunnels at back in the Winfield days. But this is an excellent slide, and I don't think you can see the bottom of this. This was a 11004 spray tip at 40 psi. If you look on the right side, we used 141 microns because that was the definition at the time that the EPA was looking at, as anything below 141 is the driftable fine. But if you take this spray nozzle and look right down the middle there, that's what water delivered out of that spray tip. Some herbicides we added actually reduced the fine, some of them substantially. A 240 ester, reduced that about 7%. On the other hand, you go all the way to the right side and look at the number of products that greatly increased the percent fines in there. Some of them taking you 10, almost 15% higher than what that spray tip on the nozzle chart would have said. Next slide, please. So I say, let's give that drift reduction space to the spray tips. They do that. They do it well. Deposition adjuvants make a drift reduction spray tip much better. They give a significant additional reduction in fine particles. They help drops that hit the target to not bounce off. Deposition adjuvants literally should be added to every application, regardless of the spray tip you use. I mean, this is one of the things basically that Corteva was able to do with the Enlist technology. They included that deposition aid into their herbicide. And even though they're using it with a drift reduction spray tip, I mean, they're recommending with AI XR, they proved to the EPA that they got significantly less off-target movement, and thus they get by with less buffer zones. Next slide, please. So this is another good indication of the addition of a deposition aid, what it can do for virtually every type of spray tip. You go from standard XR on the left, you see the dark bar is the percent, and this is under 105 because the terms had changed by the time we did this one. So now the new definition is 105. So you look at the standard one over there, over almost 22%. The deposition aid drops it down under 10. But even with the good drift reduction spray tips, just a little bit off the middle, you see the TJet AIXR, what I perceive as one of the better kind of all-around spray tips. Again, even though that nozzle by itself reduced it to about 5%, big improvement over that XR, but the deposition aid took that down well below 2. So even with the better drift reduction tips, the deposition age is still adding significant value. You get all the way down to the ones way on the right-hand side, of course, the change is minimal, but they're also, those tips are creating such huge droplets that they aren't really usable for all applications anyway. Next slide, please. So the answer is, why not just use that ultra coarse spray tip and our problems are solved. This is one reason why we started talking about the application enhancement program, because unfortunately, that's the thinking of many, but those huge droplets are very detrimental to almost all applications. Even with the dicamba, and it's required there, so you can't argue about that. Those huge droplets with the DRA over 1,000 micron medium VMB, those just aren't real practical. So remember, our goal is to maximize weed control. It's maximize control of insects and diseases. The combination of the correct spray tip and a deposition adjuvant is the answer to optimize our control and minimize our off-target movement. Next slide, please. And again, this is some old data, but the other things that deposition agents can do for you, and I'm going to cover this relatively quickly. This is, well, you can tell you it's dated. It's all the way, I think it was back in 2004. Because using this phased Doppler system, you can get the speed of the droplets as well. But water had 21% under 150. You put the Roundup Weather Max, it was 27. A drift reduction adjuvant took that down to 7. But look at this droplet speed. Went from 6.5 to 10. That does make a difference, because the longer the droplet is in the air, the more subject it is to evaporation and reduction in size of the droplet. Next slide, please. So this kind of again, old slide, used a lot, but it kind of was designed to show you how far those fine spray particles would move. Let's look at the 100 micron one, just under the 50, second line down, 100 micron droplet, categories at this time as very coarse, 5 mile an hour wind. It moved 42 feet at 5, 84 at 10, 127 even at 15 mile an hour wind. In most of the world, if we can spray at 10 miles an hour under, that's a rare day. By simply increasing that to 200 microns, significant reduction in downwind movement. You get it to 300 with a medium-sized droplet, and you've greatly reduced your off-target movement. Even at 15, 16 feet, the addition of the drift and deposition agents are really going to help you fall into those medium or even the 400, the coarse category, and greatly reduce your off-target movement. Next slide. There's some fungicide work done at the University of Nebraska. And again, this is the percent of total spray volume of 2 different fungicides, and then 3 different drift reduction adjuvants with it. The first one alone, your 15% improvement. A little more varied with the other fungicide, but again, significant improvement in your delivering of the fungicide. Next slide, please. So one term that I heard, I talked to a really big grower one time, and he was spraying edible beans, and he talked to me at a meeting about, he says, I think I need to get a new pump for my sprayer. I want to drive my fungicide down into that edible bean canopy. And he says, my pump will only get me up to 70 PSI. Do you think I need a new pump to drive them down into the canopy bed? So the next slide is my answer. No, don't increase the pressure to increase your deposition. It is just counterproductive. You just send everything in the wrong direction by increasing the pressure. You're far better off using a 40 or a 30 PSI with the right spray tip and a deposition agent if you want to increase canopy penetration. Next slide, please. Again, the other factor around this is the evaporation and the deceleration of speed is important. If you look at 100 micron droplet, it stops in 0.9 seconds. And your ultimate size then went from 100 down to 33. And it takes 7 seconds to evaporate. So look how quickly it decelerates. 9 inches, 100 micron droplet is virtually stalled out. How high are your spray booms? So even 150 micron droplet, if you look at that deceleration time, 150 micron, you've run out of energy 16 inches from the spray tip. So we need to get rid of those smaller micron sizes because the overall improvement of our coverage. Next slide, please. Some work, this was done in a laboratory with some fungicides, 2 different formulations. But again, adding that deposition aid on the one on the far right, look at the coverage increase by putting a deposition aid on the leaf or into the spray tank. I'm sorry. Tremendously improvement in coverage. Next slide. So again, this is back to that same one. I'm just trying to drive this point is canopy penetration, whether you're spraying a fungicide, insecticide, or a herbicide, is critical, and our drift and deposition agents are going to help deliver more coverage. Next slide. Works in air also, with and without. And the aerial group does use a lot of deposition aids, and that's a totally different world. Like I say, they work in all aspects, whether by does look the one on the right may hit that tree, but at least he's not drifting in the meantime. Next slide. I'm going to talk about a program that CPDA is just kicking off. It's called the Application Enhancement Program. And what we're really trying to do is have a tool that we can show the value of getting proper coverage, which is still essential, not just, and at the same time quantifying how much you're drifting. Next slide, please. So where this came from, since 1987, we've been trying to work on through work with legislative groups, regulatory groups, on trying to reduce spray tips, spray drift. CPDA, as we're talking today, we're doing education programs. So we've been working hard for a long time trying to move spray applications in better direction. Next slide. So for over 20 years, the EPA has been talking about a DRT program, trying to get the industry to create less off-target movement. And they've struggled for years trying to come up with a program that fits all. But the line they could never pass was to recognize that drift control without biological efficacy is not a successful application. So just using that ultra coarse spray, while you have very few fines, you're not getting proper efficacy either. Next slide, please. So this program is going to be a simple, standardized, cost-effective protocol that lets participants show a simple visual tool for communicating certified test results and best management practices for technologies. It provides applicators with an easy to understand visual match a nozzle to an adjuvant and a CPP product to show the performance. Next slide. So this is our examples that we started out with, and don't worry about the type of drift reduction adjuvant that we utilized here. This is really just to show the intention of what the program's capability is. So we look at what is considered on target is any drop between 160 microns and 840 microns. So that's the black number you'll see, what falls out of that particular spray tip and with that herbicide. And then it also shows the percent too small, which is so those are the ones we want to minimize. So the red, the black is what we want to optimize. The red is what we want to minimize. So if you look at the first one is glyphosate. I mentioned earlier that it's a big factor increasing fines. And so this is with a DRA and glyphosate with 4 different spray tips. And the easy answer here would be, okay, I get 90% coverage with that AI XR 11004, and I've only got 4% under 160 microns versus the TTI, which delivers 78% on target, which isn't bad for that spray tip. It's only got 2% driftable fines, but you gave away 12% coverage by switching from one nozzle to the other. And I think that's the picture we want to give. And again, a lot of other nozzles need to be added to these programs. This is just the initial look at it. But we think this could give you applicators a picture. If I've got this nozzle in my sprayer that I'm using, and I'm using a glyphosate or a glufosinate type product, which greatly increases fines. If I put that DRA in it, here's what it looks like for me versus some of the other tips. Next slide. And that's just another example that, again, we'll look at just the top line, the glyphosate one with a drift reduction adjuvant, the AXR delivering 88% of usable droplets and only 4% undesirable or too fine. While the TTI only has 1% driftable fines, it's only getting you 70% coverage. Now, if we put one of the DRAs into that TTI that's going out with dicamba, you're probably good droplets here, probably under 50%. Next slide. So we're just kicking this off, but we think it's going to be a real way to allow applicators to help them pick their nozzle, their drift reduction agents. Your distributors of your drift and deposition technology have the ability to get these tested and help you create a better application experience. Next slide. The last thing we're going to talk about is this isn't new by any means, but the EPA continues to change and continue to bring this up and continues to bring new threats in this area. But they've recently announced that before they register any new conventional active, they will conduct an endangered species assessment to determine potential effects of a threatened or endangered species. The product that could be in jeopardy must add mitigation measures. Now, again, this is somewhat like what you see with the dicamba and the enlist technologies, but this could affect many other new actives or old actives as we look at it. So their purpose, they want to reduce pesticide exposure to non-target organisms during an application, which is correct. The big question is, how do we help avoid you as applicators having to have huge buffer zones that you have to deal with? So our work right now is to really look at can CPDA propose drift deposition aids along with the right nozzle as an option for mitigation of these endangered species buffer zones. We think it's a movement that we can help with. CPDA, ARA have a history of working with the EPA and the USDA to help mitigate these kind of things. And so we'll look forward to the opportunity to show a lot of what I just went over with you guys, the opportunity in combining technologies to try and reduce buffer zones, because they're a problem for everyone, and especially allowing you to control weeds, insects, and diseases in the edges of the field. So this is a big movement that we're trying to work on, and we're hopeful that we can help protect your right to spray what you need to spray when you need to spray it. Next slide, please. So using the adjuvants, and maybe I already told it on the other one, all we were going to talk about here, we think this adjuvants and drift reduction nozzles could be used in lieu of extensive buffer zones. Is a win-win for you guys. We've already got a lot of the data. As I mentioned before, the Enlist and the dicamba have really set a precedence for doing it this way. And if we can do that rather than have it regulated by doing it on a voluntary basis, that you as applicators are doing all of the right things and verifying that, we think we can go a long way to reducing those buffer zones with all technologies as we move forward. So we're going to look forward to working with the ARA in collaborating with this, along with the manufacturers and the adjuvant distributors and manufacturers, to try and manage and mitigate endangered species buffer zones. Next slide, please.
Yeah, so Johnny couldn't join us today, but Joe, thank you for such a great presentation. We do have a number of questions in the chat that I'll ask, and you can just give your answer live. The first is, when you claim only 15 to 25% of acres have a drift reduction agent or deposition agent, are you counting the extend crop acres and enlist crop acres in those numbers?
I was not. That is because those are virtually mandated. So that was the other acres. So they are correct. And that number would take it up, at least on soybeans, would increase that number to, in the 50s plus with those. But that is correct. I did not include those because those are basically mandated for all intents and purposes.
The next question was, what deposition agent was used in slide 16? If you want, I can pull that up. It'll just take a second. That way you can look at it as well.
Okay. That was an oil emulsion system.
The next question is, most fungicides advise against adjuvant use after the V8 growth stage?
They do, and that goes all the way back to the arrested ear issue that occurred, I don't know, 10 plus years ago, when we really started to spray fungicides widely. That is primarily around nonylphenol ethoxylates. I think most of the fungicide manufacturers see the advantage of a deposition agent. You've just got to verify with them that it's not containing a nonylphenol type of system.
The next question is, what does adding UN32 or UN28 do to the amount of driftable fines?
I don't think we ever saw a huge increase out of adding the fertilizers. I know for a fact AMS had virtually zero impact on the amount of driftable fines. Probably not a lot of wind tunnel data has been done with the other fertilizers, but I don't see anything in it that would indicate that would probably affect it one way or another very much.
The next question, does the quality of adjuvant affect the results of wind tunnel data?
Well, I mean, there's certainly variation between them. I mean, it's hard to say quality because I mean the wind tunnel data is is basically can't lie. What comes with the laser detects or the out of the numbers are going to be what they are, and so the quality will be, and that's why we think this application enhancement program is so good. We'll let people go ahead and have them run in a wind tunnel with the nozzles that they want to use, and the data will say be what it is.
The next question, do you prefer polymers, invert emulsions, or something else?
Well, I think all different nozzles react differently to different types of drift and deposition agents. So you're going to be able to find a nozzle that works with many of those, but you're going to have to have your the people selling them to you show you the data on what they work with and what they don't. I mean, like you say, I had the luxury of looking at a whole lot of adjuvant systems with a whole bunch of spray nozzles, and there's tremendous variation in all of the technologies that are available to you. And I think that in today's world, most everyone has all of the different types of technology is available to offer you one that fits with the particular nozzle that you want to utilize. So that's what you're going to have to ask your provider of those. Hey, show me what's the best option. And again, it goes back to why we think this application enhancement program is going to be so valuable, because it gives everybody a picture of what both the herbicide, the nozzle, and your deposition agent are doing for you.
Any other questions at this time? You have just a minute or so.
Yeah.
While people are thinking of questions, I'll go ahead and remind everyone that there is a QR code available on your screen to be scanned to receive your Certified Crop Advisor IPM CEU credit. You could scan that, and if you have any issues, you can email info@cpda.com to make sure that you get your credit for today's webinar. Again, this webinar will be made available, as are every webinar in the series, on ARA's website, aradc.org. You can email info@ara.dc.org if you have trouble logging on and viewing those webinars. Will also be made available on our YouTube channel, and the slides will be made available for ARA members as well. We do have one more question in the chat, Joe. This person said, I feel that reduced retention of pesticides has contributed to resistance. Would you agree?
I would, absolutely. I think sublethal doses of herbicides and fungicides have proven to increase resistance. They've done a better job of it, actually, with the fungicides that they've documented. Well, I don't know that I've seen that we've documented that on weeds, but I do think it's without question a factor that sublethal doses of herbicides on a consistent year in and out basis, especially like we did with glyphosate, certainly contributed to the resistant weeds. Where better coverage, that herbicide, we may see a lot less resistant weeds had we done an exceptionally good job of application on every application. But as we all know, that doesn't happen. It isn't anybody's fault, but it's all of our fault, really. So the other thing I would add, I think what we kind of did not cover well, we didn't go into the individual types of drift and deposition agent, like the one person alluded to. A little bit for Johnny and I felt it was self-preservation, but I think we do have to have a more detailed discussion as an industry and how all of these systems that we're out selling are working differently, and be more upfront with people as use this in this situation and this and this. And I think the industry has tried to just sell, hey, this is my favorite technology, and try and push that along. But like I said today, most everyone has multiple technologies available to you. So that I think would be a good topic for our next fall, is how do we cover these better and describe exactly what all they do well, because I do think I'm passionate about this. I know that if you put a good drift and deposition agent in every application, you're going to get better performance. It's proven again and again and again. So.
We do have one more question. Polyacrylamide-based DRA agent known to shear degrade. How does wind tunnel DRA data reflect actual field conditions where tank mix solution experiences shear due to pumps recirculation?
Yeah. I think it probably does not represent a properly sheared type of, whether it be a guar gum versus many different types of polyacrylamides now too. Some shear, some don't. But I'm afraid a lot of those on the DRA list probably were not subjected to that shear. And again, the other argument around that is, well, that's not in the spray tank that much. They don't circulate that much, so they really don't shear that much. I've done enough work that yes, they do. But again, I think in many cases, the suppliers have upgraded their technologies where that is not as big an issue as it was 15 years ago.
The next question, does CPDA program consider realistic field conditions for the testing specifically for shear degradation?
We have not gotten that far to look at whether we want to add that. I mean, this program for the application enhancement program is just in its beginning stage, and we wanted to get it started, and then we will have to address some of those types of things, that if we're going to do certain types of technologies, we probably do have to put them through their paces to make sure that at the end of the spray tank, they're still working. I think that's a legitimate concern. I'm sure Jim Reese is on here, and Susan Son, that's probably an item that we need to include in the system. That's a very good question. I appreciate that. Hadn't thought of that.
The next question is, how do we get on the certification list?
That would be, it's simply a matter, it's set and ready to go. University Nebraska Wind Tunnel in North Platte has the protocol, and they're ready to run them. So if you're interested, we'll help you get started on it. The crew there at University of Nebraska North Platte has the protocol, and it's ready to go. And email myself or Jim Reese at Precision Labs. He's kind of shepherding this. This is his passion. So if you're interested, we'll help you get started.
Joe, do you mind sharing your email with the group?
I get enough emails, but no, why not? Yeah. Yeah. jvgedn@gmail.com.
Great. Well, we want to thank you again for your hard work, Joe. Appreciate that. Appreciate our partnership with CPDA. Want to thank everyone for being on today's webinar. Again, email info@cpda.com for more information on the topics. You can access the webinar at aradc.org. And please reach out to us at info@aradc.org if you have trouble logging on. I'll leave this IPM CEU credit up, QR code for people to scan for the next 5 minutes or so, and then we'll end the webinar. But thanks again to everyone for being on and joining us today. And Joe, thank you for your expertise and your partnership with us.
Very good. Thank you, everybody, and have a great day. Have a safe spring season.